Hello, welcome back. Today we're going to go over an exercise where we're going to use the product and quotient rules. We have four different functions. Let's start with the first one, root x sine x. And before we hit the road, I want to remind you the product rule. So it's essentially if you have the product of two functions, then the derivative of the product is the first function f times the derivative of the second function g, so we just call it g prime of x, plus the second function g times the derivative of the first function, which is f prime of x. Well, in this definition, since we have f and g already being used, and since our function is defined f of x equals root sine x times sine x, I'm going to use the rule in a way that whenever we refer to f here, I'm going to say like the first function, and whenever we for g, I'm going to say the second function. All right, here we go. The derivative of f, which is f prime, is the derivative, the prime of the product of these two functions. So here the first function is root x, the second function is sine x. So the product rule says that we take the derivative of root x. So let me write it precisely, and then we can take care of the derivatives in the next step. So the derivative of the first function times the second function itself, plus we keep the first function root x and take the derivative of the second function, which is sine x. All right, this is what the product rule says. All right, to be able to take the derivative of that, we should probably use the power rule. So I'm going to write root x as x to the power of 1/2 multiplying sine x, but we still need to take the derivative of this. And then, well, keep root x here since we're not doing anything to that. And the derivative of sine from the previous section, this is the sine function. The derivative of that is cosine x. You can use the differentiation table if needed. Okay. And then let's just use the power rule to finalize this full derivative coming out of product rule. So this is 1/2 x to the power of, so we put the exponent in front and subtract 1 from the power. Again, this is called the power rule. Okay, sine. Well, let's simplify this expression here. So 1/2 minus 1 is negative 1/2. So this is x to the power of negative 1/2. So to get rid of the negative sign in the power, we write down the reciprocal. So it's 1/2 reciprocal of x to the negative 1/2 is just x to the 1/2 in the bottom, but it's root x of the derivative is going to be 1/2 root x sine x plus root x cosine x. All right, that takes care of part A. All right, so since we used the f notation here, what I'm going to do in the next step is that I'm going to call the x squared guy as my top, and 2 root x plus 1 as my bottom. So this would be like top derivative times the bottom minus top times the derivative of bottom, and this is bottom squared. All right, as I said, I wrote the quotient formula as top divided bottom prime, and that becomes top, the derivative of the top times the bottom, minus top times the derivative of the bottom, all divided by bottom squared. So let's apply that. So f prime will be top prime times the bottom minus top times the bottom prime. So x squared and bottom prime. And all divided by bottom squared. Okay. Let's simplify this expression. So first off, Well, we have x squared prime, and we have 2 root x plus 1 prime. So for this one, we're going to use the power rule for differentiation. And for this one, I want to convert this root x to the power of 1/2 first, and then apply the power rule next. We have x squared prime. By the power rule, this is going to be exponent times x to the power of the old exponent minus 1. So in other words, it's going to be 2 times x to the power of 1, which is just x, times the bottom, and multiply it by the derivative of this quantity here. But I wrote this as like 2 times x to the power of 1/2 plus 1. So the derivative of the first term is going to be the exponent times this coefficient here. So let me just write clearly with parentheses notation. So 2 is going to stay there because it's a constant multiple. 1/2 the exponent times x to the power of the old exponent minus 1. So it's going to be 1/2 minus 1. Okay? And that takes care of the derivative of this piece here. And then there's plus 1. So, well, the derivative of the sum is the sum of the derivatives. And 1 is a constant, has the derivative 0. Okay? And this is all divided by quantity squared. So let's simplify this expression. So here 2 cancels this 2, so this adds up to 1. So it's essentially 1 times x to the power of 1/2 minus 1 plus 0. And what is this term here? Let me just write it here. Well, this is x to the power of negative 1/2. So x to the power of negative 1/2, but we generally not keep this term like this and take the reciprocal here, x to the 1/2, but that's also equal to 1 over root x. This whole quantity here, which was the derivative of the bottom, is equal to 1 over root x, and multiplying this by x squared, there's going to be some cancellations here. X squared times 1 over x to the power of 1/2 is going to be x to the 3/2 only. And this is divided by the squared. Okay? So let's also expand this term out and write it clearly. All right, what I did here is that this is x to the power of 1, this is x to the power of 1/2. So I distribute this term over these two. So 2x times 2 root x, which is 4x to the power of 3/2, plus 2x times 1, which is 2x, and we subtract x to the power of 3/2 here. And this is all divided by 2 root x plus 1 quantity squared. Okay? So this term and this term are similar, so we can just cancel them. And then eventually, let me just write quickly here that this whole thing is equal to, right? So this is the derivative of f. All right, this is the end of the first, second sub-questions. So watch the next video for the other 2 sub-questions.